Hey there, so in this next video in section 11.1 we're going to start talking about similar triangles and then we'll work through questions 9, 10, and 11. Okay, so similar triangles, you'll see these two triangles I have pictured here. We're going to call these similar for the reason that the two triangles have the same shape. Okay, they don't have the same size, right? Clearly the side lengths for the two triangles are not all the same, of course, but the shapes, right, are the same in that the angles, right, these three respective angles that I've indicated here are equal. So one way to think about this is that we can take the small triangle and essentially just scale it up, right, by some multiplicative factor to get this larger triangle, right? So the shapes are the same, but the scales are different. Okay, so on that note, now if two triangles are similar, right, it just means again that one is a scaled version of the other. We can say that by saying, well, the respective ratios of, say, side lengths, like, say, capital A divided by A, okay, this ratio will be the same as the ratio of capital B to little b, and that ratio in turn would be the same as capital C is to little c. Okay, so here's an example of two triangles that are similar. The first one here has lengths 3, 4, and 5, and the second triangle has lengths 6, 8, and 10. And you can see, right, that the respective ratios 6 to 3 is a ratio of 2, 8 to 4 is again a ratio of 2, and finally 10 to 5 is a ratio of 2. Or phrased in a slightly different way, right, there's really this scaling factor here of 2. We're just taking the small triangle, scaling all the sides by 2, and getting the same shape, but just a different scale there. All right, great. So now let's jump into question 9 next. This question says you have an access ramp, right? And it's to have a rise to run ratio of 1 to 12. So this colon notation says that for every 1 unit of rise, there are 12 units of run. What horizontal distance in feet is needed for the ramp to rise 15 inches? Okay, so I'm going to go ahead and draw a picture of our access ramp. Okay, and so the fact that our rise to run ratio is 1 to 12, okay, that means that if I say go up a certain amount, like let's say I rise up 1 inch, okay, then the run, this horizontal distance, would then be 12 inches. Okay, now for our ramp, right, we know that the rise there is 15 inches. So we know that this distance right here is 15 inches. And our job is to figure out what? Our job is to figure out the horizontal distance, or in other words, the run here, and I'll just call that distance x for our ramp, okay? So now the thing to highlight here is that we have really two triangles in this picture. We have this little triangle formed right here with side lengths 1 and 12, right? And then this larger triangle, right, which is the rise and the run of our actual access ramp, right? So these two triangles are similar, right? So first, right, dropping this altitude here, right, like let's say that's a little a curve here, right, that's going to be a 90-degree angle. And then likewise here, I'm just dropping a vertical here, so that's a 90-degree angle. Now the two triangles, both the big and the small triangle, share this angle right here. And since the angles of any triangle have to add up to 180 degrees, right, that means that the third angle this angle, and this angle. These must be then the same as well, right? So these are similar triangles, and so one way to proceed here is to just set up a proportion. We could say, well, if I look at this small triangle, right, I have a ratio of 12 for the base to 1 for the height. So that would give us a ratio of 12 to 1. That then must be the same ratio as what we see for our axis ramp. So the base there is x, and the height is 15. Okay? And so now I'm going to go ahead and just solve this equation by multiplying both sides by 15, because notice on the left, 12 divided by 1 is really just 12. And so I'm going to just simply get here x is equal to 12 times 15, and that's going to come out to be 180. Now what are the units here? Well, the way I've set everything up, everything is in inches. So this would be 180 inches. But the problem does ask for that distance in feet. So I'm going to go ahead and just divide the 180 inches by 12, since there are 12 inches in a foot. Okay, and when I do that, I'm going to get 15 feet, right? Because I'm doing 180 divided by 12. So this would be that horizontal distance for the access ramp in feet. All right, great. Now I do want to, before we move on, I do want to point out one thing here in terms of scaling. So, as we've been saying, this small triangle and this large triangle, these are similar, right? So a slightly different approach to this problem is to the idea of just say, well, by what factor would I have to scale up this small triangle to get the large triangle? And if I look at, say, the height, I'm going from a height of 1 inch up to a height of 15 inches. So what would that scaling factor have to be? Well, I'd have to multiply that 1 by a factor of 15, right? Because 1 times 15 would give me that 15. But then that in turn says, right, that the scaling factor for the base, right, the amount I'm going to have to stretch out this 12 to get the full base for the ramp is also then going to have to be that scaling factor of 15. So I'm doing what? 15 times 12, that's the 180. And if you also notice, 12 inches is actually just 1 foot, and so 1 foot times 15, okay, I can see that 15 feet here, but just in a slightly different way, okay? All right, great. So now let's move on to question 10. So 10 is saying, find the unknown sides for the similar triangles shown. Okay, and I've just copied the triangles down over here. Now notice here the angles are the same, so that would imply that these two side lengths are the same. So if this is 5, then this would also have to be 5. And then likewise for the small triangle. And so then to find this last unknown side length, this z length here, well, one way to do this is to go about setting up a proportion, right? These are similar triangles. All three angles are the same there. They have the same shape. So I could set this up as follows. I could say something like z divided by, so this long leg z divided by the long leg of the triangle on the left, which is 5 square root of 2, that would have to equal what? Well, it would have to equal the ratio of, say, 3 to 5 there for, say, the heights of the triangle. Okay? Now, if you go and solve that proportion, you will find that z will come out to be 3 times the square root of 2, okay, which is perfectly fine. It's a nice way to solve it. But I also want to just point out here, right, there's I think an easier way actually to see this, right? If you just look at the relationship between the side lengths here and in this triangle on the left, right, these are the same, and then the long side is just the square root of 2 times this common side. And since these have the same shape, that same relationship will still have to hold. So in other words, z here would just have to be the square root of 2 times this common side. So in other words, this would have to be 3 times the square root of 2. Okay, great. Well, let's go ahead now and look at number 11 here. And this one is actually pretty similar to question 9. It says a 5-foot woman is running toward a street lamp. At the moment when she is 31.2 feet away from the street lamp, her shadow is 12 feet long. How tall is the street lamp? Okay, so we're looking for this height h right here. Okay, and again we have two triangles in this picture, right? We have this larger triangle, and then we have this smaller triangle here that's formed by the woman's shadow. Okay, so here I'm going to go ahead and just again set up a proportion. I'm going to say, well, h, the height of the large triangle, is to the base of that large triangle. Now, careful here, it's not 31.2, it's going to be the sum of 31.2 and 12, and that's 43.2. That then would have to be the same thing as well, the ratio of the height to base for the small triangle, which would then be 5 to 12. Okay, great. Now here, this is a little bit messier. I am going to go ahead and just cross multiply, like we saw in the last video. So I'm going to have 12h here on the left, and then on the right I'm going to have 43.2 times 5, and that turns out to be 216. And then finally, just to finish, we can go ahead and divide the 216 by the 12, and we're going to get that h is equal to 18, and the units there are in feet. Okay, great. That's going to do it for question 11 and for this video. Thank you.